Welcome everyone. My name's John Spear and I'm the Director of the Australian Industrial Transformation Institute at Flinders University, based at the Tonsley Innovation District, and it's my great pleasure to host this second in the seminar series focusing on the future of work in the digital age. And it's a great pleasure to have with us today Professor Hugh Bradlow, who's the President of the Australian Academy of Technology and Engineering. And the focus of Hugh's talk today will be the promise of digitalisation and automation. And I'll provide a bit more of an introduction to Hugh in a little while. Great to see people coming to us from all over Australia today, not only here in South Australia, but from other parts of the nation. And my thoughts go out to those of you who are affected by floods, tragic floods that are unfolding around us in Australia. We've also got guests from overseas as well, so welcome to our international guests. Great to have you all here with us this afternoon. I'd like to acknowledge that we are coming to you from the Ghana, land of the Ghana people here in Adelaide, and I pay my respects to their elders past, present and emerging. I'd like to thank Gemma Buell and Andreas Sabula for all their work in helping to organise the seminar series. It couldn't have happened without their terrific contributions. As I indicated, we're coming to you from a special place here in Adelaide in South Australia. It's called the Tonsley Innovation District, and it's the heart of advanced manufacturing here in South Australia. It was the former Mitsubishi automotive manufacturing plant, actually, and back in 2006, 2007, unfortunately, it closed as a precursor to the closure of the auto industry in Australia. But one of the great things that's transpired since the closure of Mitsubishi here at Tonsley is the rebirth, or the renaissance, if you like, of manufacturing here on this site. So there are now more people actually working here at the Tonsley Innovation District than there were when the Mitsubishi manufacturing plant was in operation. So that's been, no mean achievement. It's been an incredible amount of work to get to this point, and we're very proud of it. So for those of you who've heard about the Tonsley Innovation District and are interested to visit it, we'd be very happy to host a visit here at Tonsley. So our seminar series provides insights into the kind of work that we're doing here at the Australian Industrial Transformation Institute. And some of our future talks will focus on the potential of new technologies to support industrial transformation, the future demand and need for training and skills, and the social consequences and opportunities that arise from how we might work or assign work in the future. More broadly, we're doing a lot of work here on factors, particularly human factors and organisational factors that influence the uptake and diffusion of advanced manufacturing technologies as part of the wider Industry 4 agenda here in Australia. And you can see details about the seminar program, past seminars and future seminars on our website, and we'll also be providing details, the recording of this particular seminar to you off the website. 2 weeks ago, we explored the state and future of advanced robotics in Australia with Navinda Cottage from CSIRO Data 61. That was the first of this seminar series. But today, it's my great pleasure to welcome Professor Hugh Bradlow. And Hugh is the President of the Australian Academy of Technology and Engineering. And as I said, he's going to explore the promise of digitalisation and automation. Hugh is, as I've said, a senior figure in technology and engineering in Australia. He is also an independent non-executive director of Silicon Quantum Computing Proprietary Limited. He was formerly Chief Technology Officer and Head of Innovation at Telstra, where he was responsible for the R&D of new technologies and their introduction into Telstra's business. He's a graduate of electrical engineering from the University of Cape Town, and his degree is in the area of experimental nuclear physics from the University of Oxford. And he's widely recognised as a thought leader in telecommunications. Now, Hugh will speak for about 20 to 30 minutes, and during this time, if you have any questions, please put them in the chat section of your Zoom screen, and we'll select some of those questions and ask them of Hugh after his talk. So when asking questions, could you please also just introduce yourself or your organisation in the chat section. So it's over to you, Hugh. Thanks very much again, Hugh.
Thank you, John. I hope I'm on screen now, and I will just try and share a slide presentation if my technology skills get me there. Hopefully you can see that screen. John, can you see it? Oh, good. Okay. So first of all, I'd like to acknowledge the Wurundjeri people of the Kulin Nation from whose lands I'm making this presentation. And secondly, as John has indicated, there are a lot of people in Australia who are suffering at the moment, and my thoughts go out to them. It's a really difficult time for them. But I think that when we look at the global situation, particularly the fact that much of our supply lines come from countries which we cannot necessarily rely on to share our values, we need to ensure that we have the capability in Australia to be able to do the things we need to do without having to be dependent on countries we'd rather not be dependent on. And I think that's the real promise of digitalization and automation. So what I would like to do today is, now just to make sure, hopefully you can see the outline. I'd like to just spend a few minutes talking about why is this happening now? Why are we having this conversation about automation at this moment? And then talk about the things, what automation will bring to us in reality. So starting off with why we're having this conversation now, it's because the technology has come together in a way that makes it possible. So if you look at the last 40 years of advances in digital technology, and I've outlined our major platforms that we are using today, those have enabled us to digitize information. And that's been critical, for example, during the pandemic when a large proportion of the population needed to and was able to work from home. But that's only part of the journey. And the next step will be the digitalization of our physical environment. And so the next wave of digital technology will enable us to effectively do three things. First of all, economically, and I emphasize the word economically, measure the physical world. We've been able to measure it for a long time, but not in a way where you can do it at mass scale and affordably. The second is there's a new wave of analytical technologies that are now enabling us to analyze data in ways that we've never been successful in doing before. And I'll show you an example of that. And then the third is the ability to react in real time to the measurements that we're seeing and then to control our environment. And it's those three things together which effectively enable us to digitize the physical world. So the platforms, the new technology platforms that are enabling us to do that are essentially in three areas. Being an unreconstructed network engineer, I'm going to say the first and most important platform is the networks platform. But the second set of platform are the devices that you use to measure the world. And the third set are the cloud services and so-called middleware that emerged at about the same time as the other two platforms became capable to do the job that we needed doing. And once you have those three platforms in place, you can start building applications, including automation and for different areas of the economy. So going to that network platform, we are seeing the introduction at the moment of 5G network technology. The telcos are making quite a lot of noise about it, obviously, because they've just started deploying these technologies. But 5G is not just about being able to get a faster download on your phone or on your computer. 5G was really designed from the beginning, and I was there at the beginning of the design, to enable scalability of millions of devices on the network and to enable those devices to be controlled using ultra low latency and reliable communication. So you do have that closure of the loop that you can make that reactive element of the so-called Internet of Things. I won't go through the characteristics of 5G that make that possible. Happy to take questions on that. But as you can see, there are a variety of characteristics that 5G brings that We're not in 4G, but it's mostly about the so-called Internet of Things, this ability to digitize the physical world. The second area, the second platform, as I said, is the device ecosystem. Now, interestingly enough, if you look at how this became an affordable ecosystem, and you look at my list of different types of sensors there, those arose because of the production of billions of smartphones, so-called MEMS, imaging, acoustic. Those became possible because people were producing smartphones in the billions, and therefore they needed these devices to have these sensors in them at the cost of cents only. And as that exploded, people then started looking for other forms of sensor, like chemical and biological, which they could add to these suites of sensors. One of the important things that's happened in this environment is that you can actually now create distributed intelligence. You can actually put a processor in the sensor itself. You can run these sensors with very low power so that you can actually run them for years off a battery. They're small and they cost very little, as I said, because of that explosion of devices. So that device ecosystem, and I've thrown up a few examples there, that device ecosystem is critical going forward. And then the third area I mentioned were these new forms of analytics. Now, I'm going to summarize something in a very sort of superficial way, which is much more profound than I'm giving it credit for. But if you've got abundant computing, which you get from these cloud environments, and if you've got abundant data because you're busy collecting it from the physical world, you can introduce new forms of analytics, which have been loosely and incorrectly called artificial intelligence. Mostly we're talking about machine learning, and machine learning is really just pattern recognition. You've got to think of this, it's not really intelligence, it's pattern recognition, but it turns out that recognizing patterns is a very intrinsic part of the way we as human beings operate. And so when you're doing that pattern recognition, you can start emulating human activities. So I'm giving you an example here of speech recognition. Now, for years, and I worked on this in about this era over here, we tried to define models of speech that were parametric, and then we would use a mathematical model and try and adjust the parameters to emulate speech, and then use that to recognize speech. And as you can see, it was singularly unsuccessful. Unless you're getting into the high 90s% accuracy, speech recognition is a waste of time. In 2010, Google came along and they took a completely different approach. They said, we've got tons and tons of speech data. Let's throw it at an artificial neural network and see what happens. And what happened was that artificial neural network could recognize the patterns of speech, and within a few years, speech recognition got to almost human level accuracy. So that's a very powerful example of what a pattern recognition can do for you. But it's not only about speech, which is kind of useful, but not fundamental. The really fundamental thing is so-called machine vision. And so the ability to recognize objects is critical in this environment, objects that you're getting from a camera image. And you can see that within 5 years, about 2015, you could actually devise machine learning algorithms that it could exceed human capability to actually recognize objects. And in my own house, I have 10 cameras, all of which will recognize whether a person's entered the house, but not if there's just movement around the house. It can tell if my dog is eating the cat food, which is something that concerns me greatly, and things like that, which are done completely on open source software using a $50 tensor chip that accelerates the calculations and is accessible to just about anyone. So that is the technology situation that we are fortunate enough to find ourselves in today. That then leads to opportunity. And so what I want to now talk about is that opportunity. And essentially, there are two areas of opportunity. I know I've titled this about automation, but one of the opportunities that's happening now is the so-called creation of so-called digital twins. And as someone put it, there's going to be a Cambrian explosion of innovation as a result of digital twins, because a digital twin enables you to emulate in real time a physical system, and then to experiment with that physical system in a way that will allow you to devise new ways of interacting with that physical system. So you don't have to test your destruction, because once you destroy, you just reboot and go again. It's a bit like the kids playing these first-person shooter games. When they get shot, they reboot and start the game again. And that's kind of what a digital twin is in that environment. So a great opportunity for innovation comes out of that. The second area is automation. So automation tends to have a very negative connotation, as per my first sub-bullet point there, that it's about replacing human labor. But we need to think of this somewhat differently. If we're going to do wide-scale manufacturing in Australia, and John has already talked about the Tonsley Centre, which was a Mitsubishi manufacturing plant which was shut down. If we're going to be able to reboot manufacturing in Australia, we need much more labor than we have available in the country. And the way to achieve that is through automation. But there's a second factor about automation, which is that it actually is important in terms of eliminating human error. Not necessarily eliminating, I put reduce there very deliberately, because you can't eliminate human error, but you can reduce it. So that is another factor which is of great importance for innovation. For automation. Now, about actually more like almost 10 years ago, two Oxford academics, Frey and Osborne, became very famous because they produced a paper which said that 47% of jobs were going to disappear as a result of automation and computerization. And that really the only jobs that would survive would be ones that required creative intelligence, social intelligence, or perception and manipulation. Now, it was a fairly crude study. Basically, what they did was they got a group of automation experts in the room, and they went through all the job categories, which are very well defined in the US labor force statistics, and said, can you automate this? Can you automate this? And then they took all the jobs in the categories that the experts said could be automated and just eliminated those jobs, and came to that 47% figure. However, as I say, it was a crude study, and McKinsey a few years later came up with a much more nuanced view of how automation would affect work. So they looked at activities, not whole jobs, but the activities within a job. And their finding was that about 50% of the activities were automatable. But actually, somewhere between 0 to 30% of workers, and they had a midpoint of 15%, of workers would be potentially displaced by automation by 2030. And then another 0 to 14% of workers would have to change job category. And the midpoint there was about 3%. So the expectation is, and every industrial revolution in the past has met this expectation, is even though you see jobs disappearing, new jobs are created at the same time that would well compensate for that 0 to 30% of workers that are potentially lost. But on top of it, there's this issue that I've mentioned, which is that we need to be able to expand our capabilities without necessarily having the people to do it. So that's a fairly critical opportunity from the labor market. Now, I'm going to do something here where I want to give you two examples of what automation can and does mean. So the first one is I'm going to show you a video of what people's expectations were for autonomous vehicles, fully automated vehicles. So I'm going to have to do some juggling here. So bear with me 1 second while I stop sharing my PowerPoint and move to a video, which I'm going to share with you. If I can find it. Here we go. Share that. And this video is a mock-up of what people thought automated vehicles would mean. So what you're looking at there is a mock-up of an intersection. You'll notice that people are meandering across the road, cars are platooning, cars are crossing each other, and that everything is flowing neatly and well. Now, if you could actually achieve that, you would have a huge impact on traffic congestion and on safety. So that was kind of what the hope was. We would be this new automated world. But in fact, the reality is a bit different for a couple of reasons. So the first is that the logic that you need to fully automate a car is not just about machine learning. It's not just pattern recognition. You need to apply logic as well. And human beings apply logic in a sort of semi-cooperative way. And that means that the logic we apply when we're driving cars takes into account the way other people might behave and doesn't necessarily expect them to behave in a completely rational way. And trying to emulate all the edge cases to make that happen is extremely difficult. So the video I showed you is what's called level 5 automation, which means that everything's automated, all vehicles on all roads in all circumstances, all weather conditions. That's where we're still quite a long way from. But on that journey, we've come across a new technology, which for some reason, now this video started playing for some reason, it didn't beforehand. We've come across a new set of technologies which are collectively called Advanced Driver Assistance Systems, or ADAS systems. And most modern cars are coming out with these ADAS systems. They're based on the sorts of technologies that you need to create an automated vehicle. So they include a lot of machine vision technologies in terms of radars, cameras, and ultrasound. They allow functions such as automated emergency braking, forward collision warnings, lane driving, etc. And it turns out these technologies, by compensating for human error, are capable of reducing accident rates by 62%. So on their own, they're a significant step forward. And as we see the vehicle fleet introduce these technologies, even if we don't have full self-driving capability, that elimination of human error will have an enormous impact on our society. The second example I would like to give you is a company that I've just become chairman of the board of, called Rocket Boots, and they do effectively machine vision to automate what I would call a time and motion study. So let me give you an example. If you're a bank and you run a branch network, that branch network differentiates you from a myriad of online competitors. But you want that branch network to A, run efficiently, and so that your cost is optimized, and to B, deliver a customer service that your customers are going to be happy with. In other words, you don't want people queuing for hours for service. So you want to make sure you've got enough people serving, but not more than you need. Now, in the old days, you'd have a human being sitting in the branch doing what's called a time and motion study, counting the number of people coming in, measuring the time it took the teller to serve people, looking at how long the queue lengths got, what waiting times were. And that's a very expensive exercise and is not possible at scale, because you just can't get that number of people to do that sort of work. And you do need to do it at scale because, for example, a bank branch in one area of the city can have very different characteristics from one in another area of the city because of different types of demographics and different language groups and all sorts of other reasons. So you need to do it across your network in order to optimize it. So what Rocket Boots are able to do is they're able to, this picture is a picture from an overhead camera. It's recognizing objects, not people. And that's an important distinction. It's the objects are people, but it's not recognizing the people. It's just recognizing that each of those objects is a person. That each of the objects bounded by a red box is a person, and then is able to measure all the activity in that branch, so they can see how many people are coming in, how long they're queuing for, how long it's taking the tellers to serve them. And so in real time, they can update the amount of people that they need to serve customers, the amount of time customers are waiting, whether it's meeting their service metrics, etc. So that's another example of how automation not only reduces human error, but also actually enables capabilities that you simply couldn't get enough humans to do. And that, as I've said a couple of times, is going to be critical going forward as we try and develop our own sovereign capabilities, or to enhance our sovereign capabilities. So I'm going to stop there with just, two important messages. Automation isn't necessarily a threat to jobs. It can be, but it's not necessarily one, because it may enable us to expand jobs that we wouldn't have been capable of doing. And by reducing human error, we get enhanced results overall. I've mentioned safety and performance, but it goes beyond that as well. So with that, I will end there and I will throw it over to questions. And hopefully, John, I've kept within my 20 minutes.
No, well done, Hugh. That was fantastic. Really appreciated that. Hugh, look, while people are thinking about the questions they're going to ask, I'd just like to get your reflections on barriers and enablers, if you like, of the uptake and diffusion of these sorts of technologies. Now, one of the things that is also masked by Frayne Osborne's work are national differences in this question, that is the uptake and diffusion of different technologies. How would you rate Australia in a global league of technology adopters, and what do we need to do that well, particularly to do it in the context of a sort of human, ensure that there's less resistance to the technology?
Right, it's a broad question, John. So Australia, as a technology adopter, is the global leader. We've always been strong at it. I worked in the telecommunications industry for 25 years. There was a need in Australia because of our vast distances from both the Northern Hemisphere and within the country itself. There was a need for outstanding adoption of telecommunications, and we did it extremely well. I shouldn't say we, because I didn't live in the country at the time, but the country did it extremely well. And I don't want to allow the underplaying of technology adoption. People keep saying we've got to be technology producers. Yes, we do. We've got to earn our seat at the table. But we cannot possibly produce all technology. So we've got to align ourselves with global trading partners. And so that's an important aspect of it as well. In terms of national differences, one of the big things is you really, I've noticed, certainly with things like rocket boots, is that for the developed countries in this sense are quite similar. Developing countries are very different because the trade-off between labor and automation is very different there. But in the developed countries, the trade-off between labor and automation is much more of economically driven. Now, how do we? It definitely disrupts society. We've got to recognize that. We've got to find solutions that recognize how we enable people who are disrupted. That 14%, 0 to 14% of people who have to change job categories, we've got to provide the infrastructure to retrain them. We've got to support them while they're retraining. There are all those types of aspects. And so it does require a national level of planning and determination to make this transition.
Thanks, Hugh. There's a sort of question that's come through from one of our participants today, very closely linked to that, which is, as you'd expect, while there might be some fears about the displacement of jobs as a consequence of automation, there are also some fears in the community about what it might mean for the quality of work. What are your thoughts about that?
Well, I think the quality of work is what I've been trying to emphasize is through, when I say reduce human error, hopefully that sort of automation will lead to much better quality. So if you're doing, for example, measurements of the operations of a bank branch, being able to automate it in that way will lead to a very small error bar, whereas if you're doing it through human labor, it's a very large error bar, and doing it with a small error bar makes a huge difference, because then you can actually do predictive forecasts in a way that you can't otherwise. So I think the quality is going to be the key here. I think in many ways it's even more important than the productivity.
Hugh, you showed that really insightful graph around the rapid expansion and the capability of voice recognition over a relatively short period of time after it really been quite flat for decades. Do you expect a sort of similar trend in relation to some other technologies? And if so, what might they be?
Yes, so if you look at so-called artificial intelligence, the sort of the holy grail is generalized artificial intelligence, the sort of level of human intelligence. And I don't expect to see that in my lifetime. It might be one of my brave predictions that I'm wrong about. I didn't think, for example, the iPhone would take off. So take my predictions with a total dose of salt. But more realistically, some of the things people are really interested in at the moment is being able to do natural language understanding, which is very different than purely speech recognition, because you have to recognize the whole sentence and the context. And there's a test called pronoun disambiguation, and there's a contest whose name escapes me for the moment, where they give the human or the machine a sentence which says, the city council banned the protest because they feared violence, or something like that. So the question is, who's they in that question? Is it the city council or is it the protesters? A human being will get that 9 out of 10 times. I don't think they've got machines that will do better than 6 out of 10. That's just an example of context and the construct of the sentence and all of it put together. So people have been developing bigger and bigger models for these natural language understanding. There's a thing called GPT-3, which is ginormous. And there are two aspects to machine learning. The one is training the algorithm, and the other is using so-called inference, which is applying the algorithm. So you may be able to do the inference, but the training times and the training sizes are getting bigger and bigger and bigger. And more importantly, they're consuming more and more energy, just electrical power to do the training. So there are new technologies emerging like quantum computing, which will potentially allow those sorts of training to be done without that huge amount of expenditure of energy. So that's another holy grail, is to be able to do these enormous algorithms without the expenditure of energy. And those will have significant impacts beyond which I've talked about today. Really, if you look at so-called artificial intelligence today, it really is just machine vision and speech recognition. It's just pattern recognition in terms of its real application in the work environment.
What do you see as the main drivers of innovation at the moment? Where is it coming from in Australia, and what might be the balance, between the large techs, for example, and SMEs in this respect?
Yeah, look, I tend to see the world in terms of technology. So if you ask me what are the drivers of innovation, as I've just shown you today, I'm going to say technology has created opportunities. Where's the innovation coming from? It very much depends on the type of innovation. So if I take quantum computing, the innovation is undoubtedly coming out of the university research community. That is driving it. And industry, in fact, is having to scramble to actually, well, it will have to scramble to absorb it when it becomes available. Other forms of innovation, a lot of innovation is what I call the Nike innovation. Just do it. You don't have to do a massive research project to understand how to apply a particular piece of technology to a particular problem. You see the problem, you go and apply the technology, and it works or it doesn't. There's a lot of experimentation involved, and I see that mainly coming from startups where the people see a problem, and I always say the people who are most successful at innovation are the people who have an itch they want to scratch. Zuckerberg wanted to stalk his girlfriend. That's how Facebook came about, that he had an itch. And so that's where I've seen the greatest innovation emerge.
One of the other sort of issues that comes up, and one of our participants today has raised this, is sort of unintended consequences of technology, technology for its own sake, for example. How do we mitigate that? What are the keys to that?
Well, you do need regulation. So I get somewhat frustrated when I hear the government say technology will solve our emissions problem. yes, ultimately it will solve our emissions problem, but it doesn't happen in a vacuum. Without the regulatory environment to force the change, often the change doesn't occur. So at the moment, the discussion is kind of, we've got technology, we want this, and we want a miracle in between to make things happen. And, you know, I don't believe in miracles. You actually have to force things along a path. The technology has to be driven by regulation, and that's key for things like, unintended consequences are often things you can't predict. I can't deal with the unknown unknowns, but for the known unknowns, for example, things like so-called ethical AI, where you know if you train a face recognition data set on white males, it's going to do extremely well recognizing white males, but not so brilliantly recognizing black females. So you have to train it on a representative population set, and you will have, as a government, put in place regulations that will force people to implement it responsibly in your society. I'll give you another example. Take social networks. I find this extraordinarily frustrating. The social networks should be regulated as publishers. They make this claim that they're a platform. Now, when I worked for Telstra, we signed the Telecommunications Act, which said that if someone spoke sedition on two ends of our telephone line, we weren't responsible. Well, that's clearly understood. But now the platforms, the Facebooks, the YouTubes, the TikToks, all of them are claiming, and Spotify worst of all, are claiming, no, we're not publishers. We're actually just a platform enabling people to speak to each other. My argument is, if you're enabling more than the Dunbar number, which is 150, then you're actually a publisher, and you should be regulated as a publisher and subject to those regulations. And what's more, and the court cases in the US over the January 6 riots indicate this, is if you want to sue someone, it's much better to sue an organization than an individual. Suing an individual is a lost cause. But if Facebook were responsible for what people said on their platform, there would be a different outcome. So, yes, that's a long answer to a good question.
That's great. That's
regulation.
That's fantastic. And of course, the other thing is, to seize the opportunities associated with this transformation that we're going through. Some call it the fourth industrial revolution, whatever you believe of the veracity of that. Fourth, fifth, sixth industrial revolution. But what do you think are the real challenges in terms of education and training to ensure that we can have the skilled and educated workforce that we need to interpret and to participate and benefit from this?
Yeah, John, my flip answer is more engineers, lots more engineers.
Oh, what about social scientists?
Those two, as long as they understand engineering.
Yeah.
But the real issue in my mind is that we've created the so-called two cultures of C.P. Snow, the arts and the sciences. And if you're going to become a lawyer, you don't need to study maths because, it's not going to help you in your legal profession, which is completely wrong, by the way. So what's happened in Australia is we've seen the participation in advanced maths decline at year 12 to 12% of high school students, which and intermediate maths only 30%. So without advanced or at least intermediate maths, there's not much you can do in the science and technology area. We have to find a way of raising that game. And, many have tried and many have failed. It just doesn't seem to be making progress in that regard. I can give you a whole diatribe on what I think the problem is, but it doesn't solve it. So we do need to make progress on that. Now, our advanced East Asian neighbors have made considerable progress on that, and they do it by actually valuing science and technology as highly as any other profession in the country. We also, once we have the scientists and technologies, we also need to actually give them empathy. So, it's no longer just about IQ, it's about EQ. And that goes back to your sociologists, social scientists. We need to find ways of helping people develop EQ. I don't believe that these things are untrainable. I believe you can teach people both IQ and EQ, and that's, I think, what we need to do.
A couple of eminent researchers in the social sciences who developed the so-called economic complexity index, which you're probably aware of, and Australia ranks pretty lowly globally on the ECI. And I wonder whether or not you've got any reflections on what we can do, although you've said that Australia is at the forefront in many respects. If you were to look at those nations that are the leaders, what can we do to improve our performance in relation to innovation and the complexity of what we make and the services we deliver?
Yeah, I'm not familiar with the complexity, and it's something I'll have to look up. What do we need to do? Well, let me start off by saying I don't think I'm sorry, as I said to you, it's enormously hot in Melbourne, and I'm in a very hot room, so I apologize for sweating.
No, apologies.
You're putting me under the pump.
I wish I could provide you with some air conditioning.
I have got an air conditioner, but if I turn it on, it's very noisy, so I'm reluctant to do that. In terms of innovation, we are not as bad as people make out. We have a lot of really good innovation in Australia and are capable of being world leading. The Silicon Quantum Computing Company, on which I'm on the board, is a world leader, and I believe will be the world leader in quantum computing going forward, and something that Australia placed early bets in and developed very strongly. So we can be innovative. The environment for innovation is multifaceted. So you need a regulatory environment, you need a financial environment, and you need the skills, obviously. Now, one of the problems we have is that countries, particularly like the US, although many of the Europeans have now caught up with them, have got all the infrastructure you need to take innovation from the lab all the way through to a business. They've got the investment bankers, the venture capitalists, the legal experts, all these things, that the whole infrastructure to take you through. And we possibly are a bit lagging in that. And we're also possibly a bit lagging in terms of tax laws and financial regulations to make it simpler. Now, I know there are good reasons for a lot of the financial regulations because people have abused the system in the past, but you've got to try and find some sort of happy medium there, I believe.
So I think we'll wind up here because I don't want you to collapse in front of us.
No, I don't think I will. I might just sweat more though.
But I will give you one last question, which is related to that, that big question, cybersecurity. Of course, it looms large in lots of people's minds, and it has done so for many, many years, but perhaps more so at the moment for reasons I won't go right into, but for obvious reasons in some ways, given the conflict that's occurring in far-flung shores. Yeah. And what more do we need to do to ensure the integrity of our interconnected systems? Yeah, look, there are a couple of things. Let me start off by saying that the Internet of Things introduces a whole new level of cybersecurity. For example, battery-powered devices, very hard to make them to provide encryption in a battery-powered device because it's too power intensive. So there's a whole new level of cybersecurity we need to build into our infrastructure. On the social side, let me go on a rant now because this is my current bugbear. If I look at my phone, I would have received half a dozen spam text messages and probably 3 or 4 scam calls within the last hour. I believe that we could fix that. And I believe, again, it comes down to governments, A, regulating and B, taking action. So you look at the scam calls, someone is selling phone numbers, ACMA are selling phone numbers, but not keeping track of where those phone numbers are going. If they implemented better systems and did their job properly, then I believe they could dampen this down dramatically. And so it's a case of paying attention to it and giving it priority in order to improve outcomes. And I just don't believe at the moment we're doing that. We may be defending critical infrastructure. I can't judge that because obviously I'm not privy to that sort of system. But I believe in terms of the everyday social infrastructure,
we could do a whole lot more to improve cybersecurity in this country.
Hugh, it's been fabulous having you with us today, and on behalf of all the participants, I'd like to thank you so much for spending time with us and contributing to the seminar series. It's incredibly valuable, and we hope you cool down very rapidly and get a chance to have a glass of water.
Thanks very much.
That's a pleasure. That's a pleasure. So thanks to Hugh Bradlow for that fabulous presentation. It's now time to close off today, and just remind people that our next seminar is on the 21st of April, and Dr. Mark Dean, who actually was one of my PhD students here at Flinders University, actually at University of Adelaide, before he came to Flinders University to work with me, is going to be providing a perspective to us. He's now the Laurie Carmichael Distinguished Research Fellow at the Carmichael Centre within the Centre for Future Work at the Australia Institute. So there will be details to follow, so keep an eye on your inboxes. It's been great to have you all here with us today. Thanks again to Gemma and Andreas for supporting today's seminar series, and I wish you a very happy day. All the best.